Okay, so the law of cosines is used to solve non-right triangles. Remember, that's what the word oblique means if it's not a right triangle. Law of cosines we can use to solve these problems if we can't start by using the law of sines. This is what the law of cosines looks like. There's three different possibilities of how to set it up. Basically, it starts by finding one of the sides, so this would be side A down here. And if you have side B and C, and then angle A, you don't have any across pairs to work with sine, the law of sines that is. So if you have two sides and the angle in between them, you can always use the law of cosines to get yourself started. So if I label these three things, angle A is 120 degrees, side B is 7, and side C is 8. We can use the law of cosines to get ourselves started on this one. And I'm going to use the rule that helps me find side A because, as you can see, that's the only side I don't have yet. So I'm going to say that side A is the side I'm trying to find. Now, these formulas are in terms of square terms, not in terms of regular ones, but this is the expression that I'm going to write down. I'm going to try to solve for A squared and then ultimately A. So A squared equals B squared plus C squared minus 2bc cosine A. Okay, now think of this as a separate number in and of itself. Okay, so the A is the unknown, so we'll keep that A squared. B is 7, so that's 7 squared. C is 8, 8 squared, minus 2 times 7 times 8 times the cosine of angle A, which is 120 degrees. Now, the cosine of 120 degrees, you can find that on your calculator. That's perfectly fine. I have 49 plus 64 minus 2 times 7 times 8 is 112, and then the cosine of 120 degrees is negative 1/2. You could call it negative 0.5. So if I multiply negative 0.5 times positive 112, I get a positive number, and then I add that to 64 and 49, which gives me 169. Now I'm going to take the square root of both sides. Now, since this is a side length, I'm not going to put plus or minus in front here because lengths are always positive. So the square root of 169 is 13, and so A is 13. Now the rest of this triangle can be solved by using the old law of sines. So, for example, I can simply say that B over sine B equals A over sine A, which would be 7 over sine of B, equals 13 over the sine of 120. So if you solve this out, if you cross multiply this way and this way, the sine of B equals 7 times the sine of 120 degrees divided by 13. So that means the sine of B equals 0.4663 approximately. So B, corner B, will equal the sine inverse of 0.4663. Now, since this is an obtuse angle, these two have to be acute, meaning that since this is over 90, these two have to both be less than 90. So I don't have to worry when I'm doing my sine inverse as to what type of angle I'm supposed to get. It automatically gives me a first quadrant angle, which is the only one I know is appropriate to the triangle I'm working with. So that's that. And then the last angle would be angle C. So if we know that corner A plus corner B plus corner C equals 180 degrees, A is 120 and B is 27.8. If I just subtract those two from 180, I get corner C to be approximately 32.2 degrees. And there you go, triangle solved. Oops, these two go together. Anyway, second example, solve this triangle if you only have the sides. This is another way to apply the law of cosines. Remember, cosine law works whenever you can't use the sine rule, law of sines. So, in this case, again, we don't have any opposite pairs here, so we can't use the law of sines. What we can do then is use the law of cosines. Now, which rule do we use? Well, it doesn't really matter. I'm going to just pick the second one, which is b squared equals a squared plus c squared minus 2ac times the cosine of b. Now you might be saying, but you have side b. Why would you use this rule? Well, because basically what I'm going to do here is find this. I'm going to find the cosine of b, which will allow me to find angle b. Right there. That's really what I'm doing with this rule. So, yes, I have b, which is 10. I have a, which is 8. I have c, which is 5. And then if I solve this out, that would be 11 on this side equals negative 40 cosine of b. So I'd have, oh wait, that's 80, sorry, times 2. Okay, and then, so the cosine of b, if I divide both sides by negative 80, is negative 0.1375, excuse me. And then we take, to find angle b, we would use the cosine inverse of this value. So I do that, and I get that angle B is approximately 97.9 degrees. Now, is that correct? Well, notice that this is the longest side over here. This is side B. So this would have to be the biggest angle, 97.9 degrees. We've talked about this before, how the longest side has to be opposite the biggest angle, and the shortest side would have to be opposite the shortest angle. So this would have to be our obtuse angle here if we had one. So I'm going to assume that that is the correct answer for corner B. Now the rest of this, again, can be solved simply by using the law of sines. So for example, I could take a over sine of a equals b over sine of b, which would give me 8 over the sine of a equals 10 over the sine of 97.9 degrees. So the sine of a, once I cross multiply here and divide by 10, it would be approximately 0.7924. So side a is approximately, well, it equals sine inverse of 0.7924. And a would have to be an acute angle, and the angle that the calculator gives me is 52.4 degrees, which is an acute angle, which works, 52.4 degrees. And then the last step would just be saying, hey, if I add a plus b plus c, that gives me a total of 180 degrees. So if a is 52.4 and b is 97.9, I can figure out what c is by subtracting those two from 180. So c is about 29.7 degrees.